Hi, I'm Ryan Nickel, CTO at DSA Ocean, and today I want to talk about self-stable buoys in oceanographic moorings. So what do we mean by a self-stable buoy? This is just a buoy that's large, typically larger, and it maintains its upright position in the water without any kind of necessary reaction load or preload from the mooring. So let's talk about a specific example. If we're looking at one example, Fugro makes a number of oceanographic buoys, and they have a really great example with their floating LiDAR buoy. So the Sea-Watch Wind LiDAR buoy, you can see a spec sheet of it. I've got open in a tab here. So what I really like about this is that it's fairly cylindrical in shape as well, so that lends itself to modeling relatively quickly and easily in a tool like ProteusDS. So if we go down a little bit further in the spec sheet here, if we just kind of zoom in, we can see the basic properties that you need to make an initial estimate of the buoy. We've got a weight of 2,500 kilograms, diameter of 2.9 meters. So how do you set up something like this in ProteusDS as a rigid body? And why would you want to do that? Well, one reason for using the rigid body model is that it tracks all 6 degrees of freedom of the body's motion. And this is definitely necessary if you're concerned about the rotational motions, so those 3 degrees of freedom of rotation, roll, pitch, and yaw, as well as the linear motions, heave, surge, and sway. When we make a rigid body really quickly, there's no physical presence of the body. You have to put in the fundamental parameters, but that doesn't take too long. I'm going to turn on the water surface here, and just as a reference there. Okay, so we've got the mass from the spec sheet here, 2,500 kilograms. If you don't know what the inertia parameters are, you do need to know what the CG position of the whole buoy is and the inertia properties. But it's never a bad estimate if you've got something simple like a cylinder to start off with, just to get going, to use some kind of estimate of a homogeneous cylinder. So with that diameter, it looks like it's about an aspect ratio of about, kind of 1 meter height. This is going to come out to be an inertia of 10,000, something like 5,000. 5,000 here, and then once we've got the physical parameters, we can add a hull. So you can create a feature this way. You can also right-click in the area here and pick out the different kinds of hull types. We've got cylinder here is what we're looking for. So I'm going to rename this to be hull, and if you right-click and go to feature definition, it's not created in our library here, but there it is. So we've got our cylinder, and we need something that looks more in line with the proportions we got here. So a diameter of 2.9. Length we're going to say is about 1. I don't have the exact numbers, but this is, again, just demonstrative. This is a little bit of a coarse default mesh to work with in terms of angular segments, so we're going to increase that a little bit here to say, I don't know, 13. That looks a little bit better. We maybe have a little bit too many in vertical here, so I might reduce that down. That just for computational speed, it'll work a little bit better. Now, there's no mooring. This is just the buoy all by itself, right? And the center of gravity is right in the middle of the buoy. I know that will be fine. In reality, it could shift up or down depending on the loadout and all the instruments that are there. So what we're going to do is just give it an initial state here, and say just -1 meter up in the air. So it's a little bit above the water surface, and then we'll save this. Make a folder here. And it's going to save everything in a subfolder here. So there's no waves, there's no wind. It's just going to plop into the water. I just wanted to demonstrate setting up a self-stable buoy all on its own as a rigid body. And if we just open this up in post PDS here, You can see it starts off a little bit above the air there and just plops in the water, and then it does have some viscous damping from the hull. It's going to settle out over time, but that's just how you get started. All right, thanks for watching.